This lecture video is about multiplying radical expressions, and when you are adding and subtracting radical expressions, the radicals have to match exactly, but you can multiply two radicals together. So remember, we have the product rule. If you have square root of a times the square root of b, this is the same as the square root of a times b. And so we'll be using that property. And also remember, another thing that's important is that if you have the square root of a times the square root of a, then this is the same as the square root of a squared, which is just going to be a. And so we'll also be using that quite often in this as well. So our first example is the square root of 7 times the quantity square root of 11 plus the square root of 11. So we need to distribute the square root of 7, and so we would get square root of 7 times the square root of 11 is the square root of 77, plus the square root of 7 times the square root of 7, so that would be the square root of 49, which is 7. Next, we have the quantity square root of 7 minus the square root of 2, and this is being squared. So remember, this means the square root of 7 minus the square root of 2 times itself, square root of 7 minus the square root of 2, and we have to do FOIL. Okay, so that's really important for you to remember. So we have square root of 7 times the square root of 7 gives us 7. Square root of 7 times negative square root of 2 is negative square root of 14. And then negative square root of 2 times the square root of 7 is another negative square root of 14. And the negative square root of 2 times negative square root of 2 is positive 2. So we have 7 and positive 2 is 9. And then negative square root of 14 and negative square root of 14, so that's two of them, so it's minus 2 square root of 14. Next example, we have the square root of 2x times the quantity square root of 2 minus square root of x. So again, I need to distribute. And square root of 2 times the square root of 2, that's 2. But there's no x there, so the square root of x stays the same. Minus square root of 2x times the square root of x, and so square root of x times the square root of x is just going to be x, so that's going to be x times the square root of 2. Next one, we have 6 square root of y plus z times the quantity 3 square root of y minus 1. So we need to do FOIL. 6 square root of y times 3 square root of y, so we multiply the 6 and the 3 giving us 18. And the square root of y times the square root of y is y. And then 6 square root of y times negative 1 is going to be minus 6 square root of y. And then we take z times 3 square root of y, so that's going to be plus 3z square root of y. And then z times negative 1 is minus z. So the only way, remember, we're going to be able to add or subtract these is if everything after the number part matches exactly. And so here I have a y, and there's no other y. This one has a square root of y, and this has a square root of y, but it also has a z, so that doesn't match exactly. This one has a z squared of y, and the last one only has a z. None of these match exactly, and so we need to leave it just the way it is. It doesn't simplify any further. In our next example, we have cubed root of x plus 5 times the cubed root of x plus 2. So again, we need to do FOIL. We're going to take the cubed root of x times the cubed root of x, which is the cubed root of x squared. And then cubed root of x times 2, so that's plus 2 cubed root of x squared. Cubed root of x. and then 5 times the cubed root of x, so plus 5 cubed root of x. And then we have 5 times 2, which is 10. So this cubed root has x squared underneath it. These two only have x. So we can combine these two because their cubed roots match exactly. So it's going to be the cubed root of x squared. And then we have 2 cubed root of x and plus 5 cubed root of x. And so that's going to be plus 7 cubed root of x. And then this plus 10 on the end. In our next example, we have the quantity 5 times the square root of 3 plus 9 times 6 square root of 3 minus 4. So do FOIL. And so we multiply 5 times 6 gives us 30. And the square root of 3 times the square root of 3 is 3. So that is going to be 30 times 3. And then 5 square root of 3 times negative 4 gives us negative 20 square root of 3. And then 9 times 6 square root of 3 is going to be plus 54 square root of 3. And then 9 times negative 4 is negative 36. So 30 times 3 is 90. And here our square roots match exactly, so we're going to be able to add those together. Negative 20 and positive 54 is plus 34 square root of 3, and then we have minus 36. Now we have 90 and a negative 36, so we're going to be able to do that subtraction. And 90 minus 36 gives us 54. So we have 54 plus 34 square root of 3. In our next one, this multiplication is going to be very important for when we're solving radical equations. And so what this means to do is to take this thing times itself. So we have the square root of x minus 4 plus 3 times itself, square root of x minus 4 plus 3. And so you have to remember to do FOIL here. So square root of x minus 4 times the square root of x minus 4 is just going to be x minus 4. And then square root of x minus 4 times 3 is plus 3 square root of x minus 4. And here we have 3 times the square root of x minus 4 is another 3 square root of x minus 4. And then 3 times 3 gives us 9. So we have this x. We have negative 4 and positive 9, so that's plus 5. And then we have 3 square root of x minus 4 and another 3 square root of x minus 4, so that's plus 6 square root of x minus 4. The next example, so we have 2 terms in this one and 3 terms in this one, so it's like doing FOIL. You have to take these 2 terms times all 3 of these in this one. So we're going to do cubed root of x times the cubed root of x. That gives us the cubed root of x squared. And then the cubed root of x times negative 7 square root of x. So we're going to have negative 7. And then when you're multiplying radicals together, we would need to convert this into with rational exponents. So the cubed root of x is x to the 1/3, and square root of x is x to the 1/2. And when we're multiplying those, we're going to need a common denominator. And so 1/3 is the same as 2/6, and 1/2 is the same as 3/6. And so 2/6 plus 3/6 gives us 5/6. So this middle term is going to be the 6th root of x to the 5th. And then we have the cubed root of x times 2, so that's plus 2 cubed root of x. Now multiply all of these by 7, so we have plus 7 times the cubed root of x, and negative 49 squared of x, and then 7 times 2 is 14. Okay, so we have cubed root of x squared, and it's the only cubed root of x squared term I have, minus 7 sixth root of x to the fifth, and that's the only sixth root of x to the fifth term we have. Here we have two cubed root of x terms, so we can add those together, so that's plus 9 times the cubed root of x, and minus 49 squared of x. There isn't any other squared of x terms, and then plus 14. And that is all you'll be able to do to simplify this one. And that is the end of our lecture on multiplying radical expressions. Let me know if you have any questions. Thanks.